It's video 4 and this is part B, so make sure you've watched the previous video or videos relating to sample proportion. And just remember, we looked at some of the reasons behind why when we've got a large population, the mean and standard deviation of the sample proportion, p hat, the mean's given by p, okay, which is the population proportion, and standard deviation of the sample proportion is given by the square root of p times its complement over n. Okay, the whole thing has a square root taken of it, okay, aka the standard error. In the previous video we did part A of this question. Suppose that 70% of 17-year-olds in Australia attend school. If a random sample of size 20 is chosen, find the from this population, find. Okay, so n equals 20, we recall from last time. So we're going to do part B and then C. I'm going to do part B tech-free, and I'm going to do part C tech-active, just so we're covered in both instances and we can look at the differences. Okay? Capiche? So in part B, we've got, as we said, n's equal to 20. Now, because it's a large population, Australia. Okay, so we've got a large population. That means we can say that the mean equals little p. And for Australia, we're looking at 70%. So we can assume that it's the same. Therefore, Q is 1 minus P. Okay. Or you just write 1 minus P. Indeed, either of those is fine. It's going to be 0.3. Now let's take a look at this question more closely. Probability that the sample proportion lies within 1 standard deviation. Okay, so it's a standard deviation away from the mean. We've looked at a little bit of that before. So it's a standard distance from the mean, okay, of the population proportion. So what we need to do is calculate those measures. Okay, so standard deviation is what we're going to calculate first up, and we've got the standard deviation of p hat based on what we discovered last time round. Gee, I didn't leave much room there, did I? Oh no. Abracadabra. So that's fixed. And we've got to enter our values in, and we've written them just above. So it's n is 20. P, because it's a large population, is 0.7. And the complement of that is 0.3. So I'm going to put a little multiplication sign in there. And we crunch that, and I get, looking over at my calculator, 0.1025 I get. 0.1025. Now the limits limit the lower limit and then upper limit. We've got to work them out. Okay, so the lower limit equals the mean. Take the standard deviation. And calculating that, I get 0.5975. The upper limit, guess what? We add it on. We add the standard deviation onto the mean. That's 1 standard deviation above. And, well, we get 0.8025. Now, clarifying here, we're required to find the proportion p hat such that we have the lower limit there, 0.5975, up to the upper limit, 0.8025. 0.025. Okay, now we convert that into our X score, because from the previous work we did, P hat is the value X over N. So if we're trying to convert it into a score, we need to go P times N. And we'll do that there. And so we need to go 0.5975 times 20, because N is 20, remember, from just before, N was 20. And according to my calculations, we get 11.95. All right, that's 11.95. We've got X now, and 0.8025 times 20, and I get 16.05. Okay, so we're talking about discrete values. And we're looking at the question itself. Okay, and we're talking about, what are we measuring? The number of successes or fails in a sense, because it's effectively a Bernoulli trial. Okay, it's a binomial distribution, so we have to go to discrete values. Now the question is, do we round up or round down? 11 or 12? It's going to be 12, because we will go past that limit if we pick 11. So 12 is where we're at. Okay, and then X, and that's less than or equal to, is it 16 or 17? Again, if we go to 17, we're going past that limit of 16.05, so it's only 16. Now, the slow way, if we don't use technology, oh, whoops, I'm filming this on a boat and a big wave just hit my boat. No, not really. But if we've got no tech, or no graphics calculator, we need to look at this and then do a bunch of calculations. The lower limit at 12 comes out as that using our binomial distribution formula. Okay, the upper limit 16 comes out like this. And those probabilities are static, aren't they? Now, because it's discrete, we need to do the same for the other X values in between 12 and 16, and that's 13, 14, and 15. And hey presto, that would be them there. So we sum them together. Down the bottom you can see 0.7796. 0.7796. My pen is lagging. Final part. Find the probability that the sample proportion lies within 2 standard deviations of the population proportion. Now, I said I was going to do this one tech active. Let's have a look. Alright, so we need the lower and upper limit. Now it's 2 standard deviations, so we're going to take off 2 times the standard deviation, which was 0.1025, you might remember. And for the upper, 0.7, which is the mean, times 2 lots of 0.1025, and crunch that. And I get those values right there. So like last time, we're finding the probability that the sample proportion lies between those two values, inclusive. Converting them to X scores, in other words, multiplying by 20, and to the nearest integer without going beyond. So we can go down to 10, not 9, discrete values. and we go up to 18, not 19. Okay, so from 10 through to 18. Now here's the tech active part. So what we want is bino CDF, at least on a TI Inspire. Okay, and we want to put in the following, which we've seen many times before. Okay, CDF, because we want a bunch of values. So n is 20 and 0.7 was our probability of success, and it was from the lower limit, which was 10, and the upper limit was 18, and we get 0.9752, like so. Or you can just enter the parameters directly in with a set of brackets and a bunch of commas like that. Yay!